Okay guys, so I feel the need to apologize. I've been interrupted now 3 or 4 times, and so I'm sorry this video is going longer and seems kind of jumpy. Anyway, I'm going to start over on this problem. I do apologize. So here we go. Here we have a trapezoid where all we know is one base and what looks like the hypotenuse of this right triangle. If I draw on this side right here, we have a right triangle. Now, this is a 30, 60, 90 right triangle. And if you recall from our right triangle unit, if the side across from the 30-degree angle is the x side, the hypotenuse is the 2x side, and the side across from the 60-degree angle is my x squared root 3 side. Now, 2x is equal to 10, so that means x must be 5, which makes the height of this trapezoid 5. So height is 5. We also know that the first base is 14. Now, I know that this side up here is 14 square root of 3. Okay, so we have this little piece right here, but if you look, the last base, base 2, has to equal 14 minus, why did I write 14 square root of 3? I'm sorry guys, that should be 5 square root of 3. It'd be helpful if I was paying a lot of attention, wouldn't it? So let's put a 5 here. 5 square root of 3. 14 minus 5 square root of 3. Now, this is the moment where getting your calculator out is a fabulous idea, and that's exactly what I'm going to do now. So we want to figure out the difference between 14 and 5 square root of 3. And we end, well, I guess it's not going to give it to me that way. I have to do Control Enter, and I get 5.33975. So if we come back into our document here, we can say that base 2 equals 5.33975. Now, I'm going to plug these into my area formula. Area equals base 1 plus base 2 divided by 2 times the height. That's area equals, base 1 was 14, base 2 was 5.33975 divided by 2, and all of that is then going to be multiplied by my height of 5. So I'm going to jump back into my calculator now and do just that. I'm going to do 14 plus that number. I'm going to pull it directly out of my calculator, divided by 2. Then I'm going to multiply it by 5. And I get 48.3494. So if we go back into our document, my area is equal to 48.3494. And my units are centimeters squared. Thank you for bearing with me, guys, on that one. Let's go to the next problem now. Okay, rhombi and kites. They are wonderful. You can use the same formula for both. The area of a rhombus and the area of kite is found the same way. It's the area equals 1/2 of diagonal 1 times diagonal 2. You've probably never seen that before, but it is your new best friend. So, looking at this first problem, my first diagonal is going to be 5 plus 3, which is 8. And my second diagonal is 3 plus 3, which is 6. So area equals 1/2 diagonal 1 times diagonal 2, which ends up getting me 24, yes, centimeters squared. Now this guy, diagonal 1 is 11 plus 4, which is 15. And diagonal 2 equals 6 plus 6, which is 12. So my area is 1/2 of 15 times 12, which gets me, I believe that's 90 meters squared. we can do them on rhombi as well. This is 1/2 times 25 times 22, which gets me 275 feet squared. Now, this problem, we have a 60-degree angle right here. So we're going to have to do a little bit of work. This is another 30, 60, 90 triangle because we know that in a rhombus, the diagonals are perpendicular. So here, this guy, he's my hypotenuse. That must be my 2x side, which means that x must be 3. The side across from my 30-degree angle must be my x side, so that side's 3. And then the other side is the side across from 60-degree angle. That must be my x square root 3 side. So this side here must be 3 square root 3. So my first diagonal must be 3 plus 3, which is 6. And my second diagonal must be 3 square root 2 plus 3 square root 2, which is 6 square root 2. I'm now going to plug these in to 1/2 diagonal 1 times diagonal 2, which gets me 1/2. Diagonal 1 is 6, diagonal 2 is 6 square root 2. I end up getting 18 square root 2. Okay, composite figures. We've already seen a couple of these, but composite figures are as easy as breaking things down. Break it into smaller shapes whenever you can. There will normally be more than one way to do this. So for example, this guy, I could see splitting him here along this line, or I could even see splitting him here. If I split it with the green line, I'll be calculating a rectangle and a triangle. If I split it with the pink line, I'd be calculating a rectangle and a trapezoid. Now I'm looking, I have nothing that tells me this height right here and no hints. Well, I guess I could use this 3 here to get that that's 2 and that's 3. But I think I'm going to stick with the triangle and the rectangle because we seem to be a little bit more comfortable with those. So I am just going to get rid of him for the time being. All right, so if I know that this is 4 and this is 7, that means this piece right here must be 4, and this piece right here must be 3. If I know that this is 5 and this is 3, that means this piece right here must be 2. So my rectangle has dimensions, height of 5, width of 4, 5 times 4 is 20. And my triangle has 2 by 3, but remember we have to do 1/2 base times height, 2 times 3, which just gets me 3. So the composite area is 20 plus 3, which gets me 23 inches squared. Now, if I want to do shaded region, all I have to do is a subtraction problem. I take the biggest thing I have and I subtract the smaller thing. So here, my big thing is this huge square here, which is a 3 by 3. 3 times 3 is 9 centimeters squared. And I'm going to take out this little square right here. It's a 2 by 2. 2 times 2 will give me 4 centimeters squared. So my shaded area is 9 minus 4, which gets me 5 centimeters squared. And I'm actually going to skip these ones, guys. I'm going to let y'all need to do these on your own. These ones down here. I will be checking them for homework. And perimeter. Perimeter basically is adding up all of the sides of any polygon. If I give it to you in just coordinates, you get to do the distance formula many times. Yay! So here I've given you a triangle DEF, because it only has 3 points, therefore it has 3 sides. And I'm going to use the distance formula to figure out the length of this side. I'm doing DE, and so x2 minus x1, they've made E x2 because look, they've plugged in a -3 and a 3, and therefore D must be my other point. The x value for D is -3, the y value is 1. This ends up being 3 minus negative 3. That just goes to 0. It cancels out. 3 minus 1 gets me 2 squared. Square root of 2 squared is just 2. So DE is 2. Now I'm going to do EF. Sorry, that's a horrible E. EF will equal the square root of the difference of the x's, negative 3 minus 2 squared, plus the difference of the y's, 3 minus 3 squared. Again, 3 minus 3, that gets you 0. That goes away. So EF equals negative 3 minus 2 gets me negative 5. Well, that ends up being the square root of 25, which is just 5. So we have my next piece. Now let's do FD. FD equals square root. My difference in x's, I'm going to do 2 minus negative 3 squared plus difference in y's, 3 minus 1 squared, which equals the square root of 2 minus negative 3, that ends up being 5 squared, plus 3 minus 1 gets me 2 squared. That becomes the square root of, that's 25 plus 4, which equals the square root of 29. So I'm going to jump into my calculator now because that's clearly not going to give me a nice number. I have 2 plus 5 plus the square root of 29. Oh goodness, did it again. Control Enter. 12.3852. So we get the perimeter is 12.3852 as our final answer. And we just did circumference, so this should be really fresh in your head. Circumference is basically the perimeter of a circle, and you have two formulas for it, 2 pi r or pi d. Here they give me that the diameter is 16, so my circumference here should just be 16 pi. And that's all I've got for you. Thank you very much, and please finish the rest of the questions in the packet for homework tonight. Have a great evening.